Finally, we are going to look at some other advanced statistics that don't fall easily into the categories of correlational or mean difference statistical tests.
In one sense, they still look at relationships. So these other advanced statistics include, first, factor analysis. Essentially what factor analysis is, it's a data reduction technique. Assume that you took 30 different measures of some psychomotor tests, and you wanted to look at what are the factors that underlie those 30 tests. It might be they could be reduced down to 5 different dimensions. So factor analysis lets you determine unobservable but theoretically existing factors that underlie a larger number of variables.
Structural equation modeling, or confirmatory factor analysis, is a technique that is used basically to see how well data fit some hypothetical model.
Cluster analysis is a correlational procedure where you're trying to find out what are the commonalities amongst observations. For example, if you gave a large number of psychomotor tests to the members of the track team, and then you determined what clusters were derived from those different psychomotor tests. The clusters that you might hypothesize would be that you would find there are variables that are related to sprinters, distance runners, field events, throwers, and so forth. So you would conduct a cluster analysis and determine what the relationships are amongst these people, which tend to cluster together.
Meta-analysis is a technique where we use studies as the data points.
For example, there have been a multitude of studies that investigated the relationship between physical activity and blood pressure. What meta-analysis results in is taking each one of those studies and calling it a data point, often referred to as an effect size, and using the effect size as the dependent variable, and then determining what's the overall summary, what's the overall conclusion about the relationship between physical activity and blood pressure based upon this quantitative analysis of a multitude of studies that are investigating the same independent and dependent variables.
On this slide, we summarize what we've previously said. Basically, the objective of these advanced statistics are either data reduction, to see how well the data fit a hypothesized model, or to combine results from related studies to draw an overall conclusion.